So I'm going to do some calculation study. We have an exam 3 coming up in a couple days here, and I just thought that I would take a video of some of my studies, my thought processes, in hopes that it might help somebody else. If it doesn't, that's no problem. Anyhow, let's see here. So this is actually the very first lecture in this exam series here, and it's a basic like the very first example. Back we're looking about moles. So we haven't even gotten into millimoles or milliequivalents, milliosmoles. We're looking at moles, and actually we've already been given the formula here to find millimoles, and that is this going to be right here. I'm going to be using that here in a minute. And this question says, how many grams of sodium chloride? So I know that I'm going to look for grams, and I'm going to go ahead and write that down so that when it comes back to it and I have to put my answer in during the exam, I know I'm looking for grams. And I'm looking for sodium chloride. The molecular weight is 58.5 grams per mole. So my molecular weight is equal to 58.5 grams per mole. And I need to find out how many grams I need to prepare the solution. I'm also given that the sodium chloride solution is 90 milliliters that I'm needing, and that each 5 ml should contain 0.6 millimoles of sodium chloride. So that could, either look like 5 mLs per 0.6 millimoles, or how we're actually going to be using it is going to be 0.6 millimoles per 5 ml. So either one of these right here is, we could write it either way depending on what units we need. And I've just noticed that some people get stuck and they just have to be able to write it one way, but in reality, this is just a fraction. You can do, 5 mLs per millimoles, or millimoles per ml. So use what you need to use to complete your problem. Okay, so what I'm going to do first, I'm going to find out how many millimoles that I have, because I need to know how many millimoles I have in order to finish solving this problem. And I know that I need 90 altogether. So I'm going to just do 0.6 millimoles, and there are 0.6 millimoles per 5 mLs of solution, and I need 90 milliliter solutions altogether. Okay, so I'm a big proponent of a unit analysis, and so basically what I have here, I'm going to go ahead and find out how many millimoles I have, and that's going to be 0.6 divided by 5 times, let's try over, 0.6 divided by 5 times 90. And so altogether, we are going to have 10.8 millimoles. Okay, I have run out of room here, so I'm going to go ahead and write 10.8 millimoles is how many we're going to have, or how many we do have in that 90 mLs of solution, but we need to know how many grams it was to make that. And so I'm going to basically just put this into my formula here, and I have 10.8 millimoles in that 90 ml of solution. And my weight is what I'm looking for, and that's going to be in grams. I'm just going to put that there, but that's going to be in grams. And we know that there are 58.5 grams. Okay, so here is where I might do something a little bit different. So it's grams per mole, but I'm going to go grams per mole. Now, again, that's going to be the same thing that we were looking at when I was saying over here. It doesn't have to be grams per mole. I can go ahead and put that on top. And I only mentioned that because it took me many years to figure that out, and thought somebody else might like to know that as well. So it's grams per mole. And here's the thing here. We have millimoles over here, but we have moles over here. So we need to get that to be millimoles. So what I'm going to do here is I am going to let myself know that there is 1,000 millimole over 1 mole. So 1 mole per 1,000 millimoles, or 1,000 millimoles per 1 mole. And that crosses out, and putting that in my calculator here, it's going to be 1,000 divided by 58.5. And you know what, I can actually do that no problem, just by manipulating my decimal point. And I get that right probably, 19 out of 20 times, but that 20th time I'm going to get it wrong. So on a high stakes exam, I'm going to go ahead and make sure I use my calculator and double check. So it's going to be 10.8 millimoles is equal to 17.09 millimoles per gram W. And you know what? I am running out of room again. So I am just going to add well, I thought I was going to add another piece, but okay, so I don't know why that's not working for me, so I'm just going to come over here and make some more room and move it around. Nice thing about iPads is being able to do this right here. I'm just going to, wow, what is going on? Oh, me handwriting on. Okay, nice thing about iPads is being able to just move things and manipulate. Okay, so now this is going to be, again, I know in my math that it's just 10.8 millimoles divided by 17.09. I could just easily have thrown that onto my calculator and done it. This is interesting. Oops, millimoles per gram. Do you see what I just did? Always feel free to make a mistake, but make sure you go back and look and double check. That just didn't feel right, so I looked to see what happened. 17.9 millimoles per gram. There, so I just moved my gram up top, and that's equal to W, which is the weight that we're looking for. Get rid of those millimoles, and I'm going to have 10.8 divided by 17.09, and now I know that my weight is going to be 0.632 grams. Okay, so in a testing situation, I would make sure to double check my math along the way as I'm doing each step. Just a super quick math, because I am known to misinput information into the calculator. If I put it into the calculator twice, then I get the same answer. I know chances are pretty okay. If I get two different answers, obviously I'm going to double check and find out where, and make sure that I at least get 3 then of the same right answer. That's just a tipping tip. Okay, so that was example problem number 1.